Hello, my name is Nitin. Today, I will be testing the new DASY8 module SAR version 18.0 from SPIAG ahead of its official release. I am especially interested in the new Smart Spatial Specific Absorption Rate or Smart SAR feature. It determines SAR averaged over 1 gram and 10 gram tissue cubes not just at the point of highest absorption but across the entire projected surface of the phantom accurately and fast. This is a great feature for testing compliance of devices that can transmit simultaneously on multiple frequency bands. The current methods for testing such cases are typically either fast but overly conservative or accurate but very time consuming. The fast approach is to sum the peak spatial SAR values for standalone configurations with the assumption that all antennae are co-located. This approach leads to a very strong overestimation and consequently to minimum transmit power. In the past, the only accurate approach was to perform volumetric scans, but they are rarely used due to the longer measurement durations. The Smart SAR achieves the same as the volumetric scan, but it is more flexible and, according to SPIAG, more than 10 times faster than the classical volume scan without sacrificing accuracy. Let's see how it works. For this demonstration, I am using a test phone capable of operating simultaneously on LTE band 1 and Wi-Fi 6E at 6.5 GHz. I start the DASY software and configure the project and test plan. Instead of performing the regular area scan zoom scan, I select the new fast volume scan and zoom scan combination and start the measurement. I accelerate the video. The fast volume scan begins with an initial 3D scan at coarse resolution. Once the initial scan is complete, the SAR distribution is analyzed and additional measurement points are automatically added in areas with high SAR values or strong field gradients. The fast volume scan is followed by the regular zoom scan. The measurements for LTE band 1 are now complete. The fast volume scan takes only slightly longer than a regular area scan. Together with the zoom scan data, the complete spatial average SAR 1 gram and spatial average SAR 10 gram distributions can then be computed at the phantom surface across the entire measured area. I can now visualize the Smart SAR 1 gram and Smart SAR 10 gram distributions in zoom scan viewer. Unlike conventional zoom scans, these distributions cover the entire device area, not only the scanned region. This is a very exciting feature. With just a small addition in measurement time, we now have the complete 1 gram or 10 gram SAR distribution over the entire device area. This distribution can be combined with other measurements like SAR, absorbed power density, or induced power density to determine the overall exposure pretty quickly. The measured 1 gram peak spatial SAR value is 0.662 watt per kg. Next, I measure the Wi-Fi band 6E. I accelerate the video. The measurements for both bands are now complete. For Wi-Fi 6E band, I can also visualize the spatial averaged absorbed power density distributions. The measured APD 4 cm square averaged value is 1.86 watt per meter square. Since the basic restriction is SAR for LTE band 1 and APD for Wi-Fi 6E, I am mainly interested in the total exposure ratio or TER. If we assume that the antennae are co-located, the TER works out to 0.6. This is the most conservative value. On the other hand, for multi-transmit evaluation using DASY8 SAR version 18, I select the two zoom scans and choose the multi-TX evaluator from the context menu. In the pop-up window, I select the Smart Spatial Average SAR method, specify the averaging area or volume, define the SAR and APD limits, and press compute. The maximum TER value is 0.414. This demonstrates a margin improvement of 31% for this specific device. This margin can be used to optimize the device under test transmit power for better network connectivity. DASY8 module SAR version 18.0 represents a major step forward in compliance testing. By reducing unnecessary overestimation in multi-transmit evaluations, the new Smart SAR feature provides additional compliance headroom for original equipment manufacturers without performing time-consuming volume scans. This extra margin can be used to optimize device performance, increase transmit power where needed, and improve overall network efficiency while maintaining compliance with safety or exposure limits. Thanks for watching this video.